Vectors. Vectors. What is a vector? A vector is a directed line segment. We can define vector as a directed line segment. The meaning of it is, consider the figure OA. It is a ray. Actually, it is a line segment with an arrowhead. O is known as the origin or the tail of the vector, and A is head or terminus of the vector. O is origin, A is terminus. O is tail, A is head of the vector. The length of the line segment O to A, OA is the magnitude. The length of the line segment OA is called the magnitude of the vector. There is an arrowhead at A. This arrowhead indicates that the direction of the vector is from O to A. The arrowhead indicates the direction of the vector. Here in this case, it is directed from O to A. Like this, we define a vector. Equal vector and negative vector. Let us consider the vector OA, which is represented by a bar. Consider the blue one at the left of it under the vector OA. This is not equal to the vector A bar because the direction is the same but the magnitude is different. This magnitude, the magnitude of this vector is less than the magnitude of OA. Hence, this vector is not equal to the vector OA. Take the right one, violet one. Its magnitude is it is equal to the vector A bar, but its direction is not the same. Hence, this is also not equal to the vector A bar. Consider the red one at the bottom left. This is having the same magnitude and same direction. Hence, this is equal to the vector A bar. Take the right one at the bottom. It is having same magnitude but opposite in direction. It is equal to minus A bar. It is equal to minus A bar. So, whenever we take a vector, this vector can be represented in the same plane, the plane in which the vector is situated. At any point, we can represent this vector at any point with the same magnitude and direction. If you construct a vector having same magnitude and opposite direction, it will be minus A bar. Like this, we construct equal vectors at any point in a plane. What is the use of a vector? How it is useful for us? We know there are several physical quantities which we have already learned. Among them, some of the physical quantities are termed as vector physical quantities because they have both magnitude and direction. Those vector physical quantities can be represented on paper with vectors. The vector physical quantities can be represented on a paper with a vector. For example, if you take a force of 100 newtons acting due east, this force can be represented by a vector. Consider the natural directions north south and east west. So this is stated as due east, that is from left to right. So take 1 centimeter is equal to 10 newtons. A length of vector of 1 centimeter equal to 10 newtons. Then 100 newtons will become equal to a vector of length 10 centimeters. So construct 10 vectors each of 1 centimeter in length. Then this total vector it represents 100 newtons of force. See the direction. It is parallel to east-west, west-east direction, west to east. Hence, it represents due east. Instead of taking 1 centimeter as 10 newtons, we can choose 1 centimeter is equal to 20 newtons. Then the length of the vector becomes 5 centimeters. Now construct a vector of 5 centimeters. Actually, one direction is sufficient, but to have an understanding of 5 centimeters, I have constructed 5 vectors. If you choose 100 newtons as 1 centimeter, then we can represent 100 newtons by a vector of 1 centimeter. So it depends on the choice of the scale which we choose. The length of the vector depends on our choice. So we can represent the force of 100 newtons with a vector of any length. Addition of vectors. How to add the vectors? To understand this, let us take two vectors, p bar and q bar, as shown in the figure, the red ones, p bar and q bar. Now, p bar plus q bar means add q bar to p bar. P bar plus q bar means add q bar to p bar. To construct this vector p bar plus q bar, first construct the vector p bar. Now let us take OA bar. The vector OA represents the vector p bar. At the head of the vector p bar, that is at the head of OA bar, at the head of vector OA bar, construct the vector q bar. Construct the vector q bar at the head of A bar. That means the tail of q bar should be constructed at A. The tail of q bar should coincide with A, and AB bar should be parallel to q bar and its length should be equal to q bar. The length of A bar should be equal to q bar, the direction should be parallel to q bar, and the tail of q bar should be at A. Now we have constructed q bar at the head of p bar. We have constructed q bar at the head of p bar. Now take the tail of p bar. The tail of p bar is O. The head of q bar, that is B. Now join this by a vector from O to B. So the vector with tail of p bar and head of q bar represents p bar plus q bar. So p bar plus q bar is a vector which has the tail of A bar and head of q bar. Tail of p bar and head of q bar. Like this we add vectors. Now let us construct the vector q bar plus p bar. Q bar plus p bar, that is, we have to add p bar to q bar. We have to add p bar to q bar. So first construct the vector q bar. That vector is OB bar. Q bar is constructed at O as OB bar. Now O is tail, B is head of vector q bar. At the head of vector q bar, construct the vector p bar with its tail coinciding with B. Construct a vector equal to p bar at B with the tail of p bar at B. So BA bar is having the magnitude of p bar and it is parallel to p bar. Its tail attached to B bar. So this is p bar. So p bar is constructed at the head of q bar. Now join the vector, take the vector with tail as O and head as A. The vector with tail at O and head at A is q bar plus p bar. Q bar plus p bar. So q bar plus p bar is a vector having the tail of q bar and head of p bar. Like this we construct q bar plus p bar. From both the figures, p bar plus q bar and q bar plus p bar figures, what we understand is p bar plus q bar will be equal to q bar plus p bar. From these two figures, by comparing the figures of p bar plus q bar and q bar plus p bar, we understand that p bar plus q bar is equal to q bar plus p bar. Laws of addition. By taking several vectors and constructing the addition of the vectors, then what we understand is they obey commutative law. That means p bar plus q bar is equal to q bar plus p bar. They obey associative law. That means p bar plus q bar plus r bar is same as p bar plus q bar plus r bar. That means p bar plus q bar is a vector obtained by adding r bar to q bar. If this vector is added to p bar, then this vector can be obtained first by adding q bar to p bar and then constructing r bar by adding r bar to p bar plus q bar. So like this we notice that final vectors will be equal. This represents associative law. Then distributive law. If p bar plus q bar is a vector, k times this vector will be equal to k times p bar plus q bar vector will be obtained by adding k times q bar to k times p bar. By adding k times q bar to k times p bar, we will get the vector k times p bar plus q bar. Similarly, if there are two constants k1 and k2, numerical constants, then k1 plus k2 into p bar is equal to k1 p bar plus k2 p bar. k1 p bar plus k2 p bar. So these laws are obeyed by the vector addition. Subtraction of vectors. Subtraction of vectors. It is nothing but adding the negative of one vector to the another vector. Suppose if we want p bar minus q bar, that means if you want to subtract q bar from p bar, that is p bar minus q bar. If you want to subtract q bar from p bar, then it is written as p bar minus q bar. So take minus q bar. Take minus q bar and add minus q bar to p bar. Then we will get the vector p bar minus q bar. Then we will get the vector p bar minus q bar. So first take minus q bar vector, draw the minus q bar vector. I have shown here p bar and q bar, and then at the middle I have shown minus q bar vector. Now construct p bar vector, that is written as OC. That is written as OC. C is head of the vector p bar. At C, construct minus q bar vector. Construct the vector minus q bar at the point C, at the head of p bar, that is at C. Then join the origin of p bar, tail of p bar, to the head of minus q bar, to the head of minus q bar. Then we will get p bar minus q bar. So it is nothing but adding minus q bar to p bar. P bar minus q bar is nothing but adding minus q bar to p bar. Subtraction of vectors. Let us construct q bar minus p bar. Let us construct q bar minus p bar. To construct q bar minus p bar, first let us construct minus p bar. It is shown at the middle of this slide. Minus p bar is constructed first. Then construct q bar. Q bar is constructed as OD. The vector OD represents q bar. It has same direction and magnitude. O is tail, D is head of q bar. So at the head of q bar, attach the tail of minus p bar. So minus p bar is constructed at the head of q bar. So tail of minus p bar is constructed at D. Then the vector obtained by joining the tail of q bar and head of minus p bar is q bar minus p bar. The vector O2, the tail of minus p bar, gives q bar minus p bar vector. Q bar minus p bar vector. Now this is q bar minus p bar. This is how we construct q bar minus p bar. That means we add minus p bar to q bar, then we will get q bar minus p bar. If we compare the figures of p bar minus q bar and q bar minus p bar, we notice them to be of same magnitude but opposite in direction. Such a pair of vectors are called anti-parallel vectors. Anti-parallel vectors. If the directions are opposite and magnitudes are equal, anti-parallel vectors. So p bar minus q bar is not equal to q bar minus p bar. the vector p bar minus q bar is not equal to the vector q bar minus p bar. But the magnitude of p bar minus q bar is equal to the magnitude of q bar minus p bar. The magnitude is indicated at the right of p bar minus q bar is not equal to q bar minus p bar. If the vector is represented between two vertical lines, then it represents the magnitude of the vector. So p bar minus q bar magnitude is equal to q bar minus p bar. But the directions are not equal, hence they are not equal vectors, but their magnitudes are equal. Rectangular components of a vector. Rectangular components of a vector. Consider a vector r bar. Now this r bar will be taken as the sum of two perpendicular vectors. Such a perpendicular vectors are known as rectangular components. The vector r bar will be replaced by two components, perpendicular components. Two vectors, one perpendicular to the other. Let us consider a direction at an angle theta with r. The white vector represents the direction at an angle theta with r. In that direction, the vector component will be r cos theta. The vector component will be r cos theta. It is represented by OA. It is represented by OA. At O, a perpendicular vector is shown, that is r sin theta. It is OB. OB is r sin theta. It is another component. R cos theta and r sin theta are perpendicular to one another, so they are called as rectangular components. Both are components of vector r bar. They are perpendicular to one another, hence they are called as rectangular components. The component at an angle theta is r cos theta. The component at an angle theta is r cos theta, and the one perpendicular to it is r sin theta. If you add the vectors r cos theta and r sin theta, you will get the vector r bar. This is shown at the right. First I have constructed the vector OA, which is r cos theta. At A, I have constructed r sin theta. Then we will get OC, which is the vector r bar. So the sum of these two components, r bar, r sin theta and r cos theta, gives the vector r bar. The relation between r and its components. Let us take r cos theta component is along x-axis and r sin theta along y-axis. Then rx is equal to r cos theta and ry is equal to r sin theta. Then r will be equal to square root of rx square plus ry square. We notice that r cos theta and r sin theta are perpendicular to one another. Hence, angle OAC is a right angle triangle. OAC is a right angle triangle. So square of the hypotenuse is equal to sum of the squares of the sides. Hence, r square is equal to rx square plus ry square. But rx is r cos theta, ry is r sin theta. Hence, r square cos square theta plus r square sin square theta, where r square is common. Hence, we will sin square theta plus cos square theta is 1. Hence, we will get it as r. So r will be equal to square root of rx square plus ry square. The angle between OA and OC, if it is theta, the angle between OA and OC, if it is theta, then tan theta will be equal to AC by OA. AC by OA. That is Ry by Rx. Ry by Rx. Like this, we get the magnitude and direction of the resultant of two perpendicular components. In the textbook, a problem is given. Find the resultant of the vectors shown in the figure. Here, four vectors are given. They are named as A, B, C, D. A is along x-axis, B is along y-axis, C is in the second quadrant, and D is in the third quadrant. Now, the magnitude of A is 1, the magnitude of B is 3, the magnitude of C is 5, the magnitude of D is 6. A is along x-axis, B is along y-axis, and C is making an angle 37 degrees with negative direction of x-axis. D is making an angle 53 degrees with the negative direction of x-axis. This is the given problem. Let us try to find the resultant of these four vectors. Let us try to find the resultant of these four vectors. Now let us find the components of A and B. Vector A is along x-axis and its magnitude is 1. So the x component of A is 1. X component of A is 1. But its y component will be 0. Since y component will be 1 into cos 90 degrees. The angle made by y-axis with x-axis is 90. Hence it is 1 cos 90, but cos 90 is 0. Hence y component of A is 0. The magnitude of B is 3. So its y component will be 3 and its x component will be 0. The x component of B is 0 and its y component is 3. Vector C has a magnitude 5. Vector C has a magnitude 5. So its x component is minus 5 cos 37. It is making an angle 37 with negative direction of x-axis. So the component along x-axis, right, it lies towards the negative direction of x-axis. Hence its x component is minus 5 cos 37. But the value of cos 37 is 4 by 5. So minus 5 into 4 by 5 gives minus 4. Minus 5 into 4 by 5 gives minus 4. So x component of C is minus 4. The y component of C lies along the positive direction of y-axis. It is 5 sin 37. Y component will be 5 sin 37. Resolving C into two components, perpendicular components along x-axis and y-axis. The component along x-axis is 5 cos 37, along y-axis is 5 sin 37. So y component of C is 5 sin 37. But sin 37 is 3 by 5. Sin 37 is 3 by 5. So it is 5 into 3 by 5, that is 3. Hence y component of C is 3. Y component of C is 3. X component is minus 4. Y component is 3. The magnitude of vector D is 6 units. It is in the third quadrant. It is making an angle 53 degrees with x-axis. Its x component lies along the negative direction of x-axis and the y component lies along the negative direction of y-axis. X component is cos 53, y component is sin 53. So 6 cos 53 is x component, 6 sin 53 is y component. Because both the components lies along negative directions, hence the x component is minus 6 cos 53 and y component is minus 6 sin 53. But cos 53 is 3 by 5. Cos 53 is 3 by 5. Hence minus 6 into 3 by 5 on simplification becomes minus 3.6. Minus 3.6. Sin 53 is 4 by 5. 4 by 5. Hence minus 6 sin 53 becomes minus 6 into 4 by 5, which becomes minus 4.8. Minus 4.8. Like this we get the components of D. To find the resultant of the four vectors, first let us write their components in a tabular form. Vector x component, y component. The components of A are 1.0, y component is 0. The components of B, x component is 0, y component is 3.0. The components of C, minus 4.0, 3.0. The components of D, x component minus 3.6, y component minus 4.8. Now let us try to find the sum of these components, sum of the x components and sum of the y components. Sum of the x components is minus 6.6 and sum of the y components is 1.2. Sum of the x components is minus 6.6 and sum of the y components is 1.2. Now construct a vector 6.6 units towards the negative direction of x-axis, that is shown by Rx. Rx represents minus 6.6 and Ry represents 1.2. that is a vector along positive direction of y-axis, plus 1.2. Now construct Rx plus Ry, that is Ry is constructed at the head of Rx. Then the resultant vector obtained by joining the origin to the head of Ry, that represents the resultant vector R. This is how we get the resultant vector R. Now let us try to find the magnitude and direction of R. To find the resultant of R, we know that R is equal to square root of Rx square plus Ry square. X component is Rx, Y component is Ry. So R is equal to square root of Rx square plus Ry square. So that is equal to square root of minus 6.6 whole square plus 1.2 whole square. On simplification, it will be equal to 6.7. 6.7. This is the magnitude of R. The direction of R, that is the angle made by R with x-axis, is given by, with x component Rx is given by tan theta is equal to Ry by Rx. Tan theta is equal to Ry by Rx, where theta is the angle made by R with Rx. So tan theta is equal to 1.2 divided by minus 6.6. Tan theta is equal to 1.2 divided by minus 6.6, which becomes equal to minus 0.18. Minus 0.18. Because we know that the vector lies in the second quadrant, tan is negative in this quadrant, so it is enough if you take 0.18. Tan theta is equal to 0.18. From tables we can find the value of theta, which will be obtained as 10.3 degrees. So R makes an angle 10.3 degrees with Rx. This is how we find the resultant vector. When a number of vectors are given, if you want to find the resultant, first you find the components of the vectors along x-axis and y-axis, add the x components and add the y components, then you will get Rx and Ry. To find the resultant, we use the relation R is equal to square root of Rx square plus Ry square. For finding the direction, the angle made by the resultant, we use tan theta is equal to Ry by Rx. Using this, we find the angle made by the resultant vector with x-axis. Like this, we find the resultant of a number of vectors. Null vector and unit vector. Null vector, a vector whose modulus is 0. A vector whose magnitude is 0, whose modulus is 0, whose modulus is 0 is known as a null vector. Modulus p bar is equal to 0. This is the modulus of a vector p bar. If it is 0, then it is called a null vector. The direction cannot be determined for a null vector. So the direction is indeterminate. The direction cannot be determined. It is indeterminate. Then unit vector. A vector having magnitude of 1 is known as unit vector. If the magnitude of a vector is unity, it is called a unit vector. A unit vector will be obtained by dividing the vector with its magnitude. So if p bar is a vector, the unit vector will be p bar by modulus p bar. P bar by modulus p bar gives unit vector. Generally, modulus p bar will be represented by p. So the modulus will be represented by p. Hence, it can be written as p bar by p. Here, modulus p bar should not be 0. To obtain unit vector, modulus p bar should not be 0. Hence, p bar by modulus p bar gives unit vector. That means a vector having magnitude unity along the same direction of the vector p bar. So, the unit vector has the direction of p bar, but its magnitude is 1. Unit vectors, orthogonal unit vectors. We represent 3 unit vectors along x, y and z axis. They are named as I, j, k. We take 3 unit vectors along x-axis, y-axis and z-axis. The unit vector along x-axis is termed as I, small I. The unit vector along y-axis is termed as j, small j. And the unit vector along z-axis is taken as small k. These are known as unit vectors along x, y, z axis. use of unit vectors. How the unit vectors are useful? The unit vectors are useful in representing a vector in terms of its components, x component, y component and z component. If there is a vector a bar whose x component is ax, y component is ay, z component is az, these are scalar quantities. Then the vector component along x-axis is written as axi. The vector component of a bar along x-axis is represented as axi. The y component of a bar is written as ayj. This is the vector component along y-axis. The vector component along z-axis is represented as azk. Axi, ayj and azk are the components along x, y, z axis. So the vector a bar will be equal to axi plus ayj plus azk. Like this, we represent a vector, we write a vector in terms of its components. Advantage of unit vectors. I will explain this. First, let us try to understand the figure. Here, I have taken two vectors a bar and b bar. I have constructed a bar plus b bar. A is represented from origin and b is constructed at the head of a bar, and the vector with tail of a bar and head of b bar gives the resultant vectors, that is represented by r bar. R bar is the resultant of a bar and b bar. Now let us write a bar and b bar in terms of their components. The components of A are shown as ax and ay. From the head of A vertical dotted line is drawn, and from y-axis its distance is represented by ax. This is x component of a bar. Similarly, from the head of a bar, a dotted line is drawn parallel to x-axis. The length of this, the height of this along y-axis, the distance of this from x-axis is given as ay. Along y-axis, its length is ay. So, ax and ay represent the components of a bar. Ax is along x-axis, ay is along y-axis. So, the vector a bar can be written as axi plus ayj. The vector a bar can be represented as axi plus ayj. Now let us take the components of B. From the head of B, a dotted line is drawn vertically downwards, and Bx, the x component of B, will be from the dotted line at the end of A to the dotted line to the head of B. That is represented by Bx. Another dotted line is drawn parallel to x-axis from the head of B. The vector from the head of A to the head of B along y-axis is represented by by. So, the vector from the horizontal dotted line from the top of A to the horizontal line to the dotted line to the top of B is by. Now, b bar can be written in terms of its components. B bar is equal to bxi plus byj. B bar is equal to bxi plus byj. Now, r bar is equal to rx bar. X component of r bar is equal to ax plus bx. R component of x is equal to rx. Rx is equal to ax plus bx. And ry is equal to ay plus by. Ry is equal to ay plus by. Like this, we find the components of R along x-axis and y-axis. Then, by computing Rx and Ry, by constructing Rx plus Ry, we will get the vector R bar, which we are going to study now. We have seen Rx is equal to Ax plus Bx and Ry is equal to Ay plus By. Therefore, R bar is equal to Rxi plus Ryj. R bar is equal to Rxi plus Ryj. X component is Rxi, Y component is Ryj. So, vector R bar is equal to Rxi plus Ryj. Therefore, r is equal to square root of rx square plus ry square. R is equal to square root of rx square plus ry square. And the angle made by r with x-axis, is given by theta, and tan theta is given by ry by rx. Tan theta is equal to ry by rx gives the angle made by r bar with x-axis. Like this, by using the components, we can find resultant of any number of vectors. The resultant of any number of vectors can be obtained by using the components.